Hey folks, today's topic is the first of two lessons that we're going to do concerning lines. In the plane we're talking about, of course, is the Cartesian coordinate plane. We're not going to do any 3D lines yet, actually at all. Even second semester, we do a little bit of 3D graphing second semester, but we don't do any 3D lines. But anyway, okay, so we're talking today. Our main target is to be able to come up with equations for lines, or be able to determine the characteristics of lines. Mostly we're talking about slope here. Slope is the biggest characteristic that we care about when it comes to a line. So let's start off with a definition of that. So definition, the slope, underline slope, that's the term that we're defining. And do you remember the symbol that we use for slope? It's M. The slope M of the line through. Okay, now we got to have 2 points. Now these are just two random points. So one random point would be the point x comma y. But we need another point also called x comma y. So we use a subscript where we call the first point x1 comma y1 and the second point x2 comma y2. So the slope of the line through these 2 points is, how about is given by, and then we've got this thing called the slope formula, which hopefully you remember. Maybe you don't have it memorized 100%, but hopefully you got a pretty good idea of it. M equals, all right, so there's a couple of famous sayings that we have when it comes to the slope formula. Hopefully you've heard of the phrase rise over run, and I'll write that next to this in a minute. I want to make sure I have enough room. But this is, slope formula is known as rise over run. So what I need to do is I need to figure out how far these 2 points rise and then how far they run from each other. So if I'm looking at, let's take just 2 random points. Here's one random point. This is x1, y1. This is, I'm just going to call this x2, y2. These are just 2 random points that I've determined are in our coordinate space. Now look, there's 3 measurements. There's 3 ways to look at this. I can find this thing right here. That's not the slope. That's the distance. There's a separate formula for that. You probably hit it when we did the PQ0. Hopefully you remember that when we looked at PQ0. But that's the distance. That's not what we're talking about when we're talking about slope. Slope is rise versus run. So we've got kind of this center spot here, this corner point, that if I drop a vertical and then draw a horizontal, that gives us a right triangle. And that's where the distance formula is really just the Pythagorean theorem. This is really just a squared plus b squared equals c squared, and that's where that distance formula comes from. Don't ever try to memorize the distance formula. It's not worth it. But we're talking about slope. We're seeing how much from this point does our graph go, does our 2 points go up, and then how far left to right, we call that run. So if I wanted to figure out how far apart these 2 things were, I would have to figure out how far they change up and down, and which one of these variables does the changing up and down. The y's do. Now we always write it y2 minus y1. It doesn't have to be y2 minus y1. It could be y1 minus y2. All that matters is whatever order you do this in, you have to do this in the same order. So things move vertically, that's going to be the change in the x's. So this is x2 minus x1. So when we do this ratio of change in y over change in x, that tells us not this distance, but it tells us how slanty that line is. And that's what we're talking about when we're talking about slope. So the slope formula is y2 minus y1 over x2 minus x1. And like I said, we also call this rise over run. And then, especially in physics, we use this symbol here, which is red delta. Dang it. Delta y over delta x. Delta stands for change. The change in the y and the change in the x. Okay, so now that we've got this idea of slope, let's go ahead and calculate some slopes. Determine the slope of the line through the given points. So this first one, I'm going to kind of show it in real detail. This is what I would do if I was teaching this in Algebra 1. You don't have to do this every single time, but to understand it the first time, it might be helpful. So I'm going to call this x1. I'm going to call this y1. I'm going to call this x2. I'm going to call this y2. Then I'm going to use my formula up above. M stands for my slope. So it's y2 minus y1. So I'm minusing a negative. That's going to actually turn into a plus. Negative 3 subtract a negative 1 turns into a positive. Then negative 4 subtract 2. We get negative 3 minus plus 1 is negative 2 over 6. Now, in this class, it is unacceptable to leave an answer like this. You must clean things up, even if it doesn't say that you have to. So, big problem is we've got a negative divided by a negative. Let's fix that first. So, a negative divided by a negative is a positive, so that's nice. And then 2 and 6 are both divisible by 2, so we'd get an answer of 1/3. Now, just to show you that it doesn't matter what you call y2 and what you call y1, I'm going to go the other direction on the side over here and show you that we're going to get the same result, just with opposite signs. So instead of doing negative 3 minus negative 1, I'm going to do minus 1 minus negative 3. And then now, because I did this first, I have to use this one first. That would be 2 minus negative 4, so that'd be 2 plus 4. So I would get 2 over 6, and then 2 over 6 reduces to be 1 over 3. So we get the same result if we, it doesn't matter which way you go. You just are going to get answers that are opposite if you go a different way than I go. But at the end, when you clean it up, the results will always be the same. So in this case, I'm going to go backwards. I think on your sheet, I actually have these flipped around. So I'm going to do it the way that your sheet looks. So that would say m equals, this is actually y2, so that would be negative 1. Oh, no. No, I got it right. So 1 minus a negative 1 would be 1 plus 1 over negative 1 minus 2. So we'd get 2 over negative 3. I didn't flip those around after all. So in this class, you would lose a point for this. This is unacceptable. You may not. There's a couple of basic rules in math, and one of them is you must reduce. Another one is you can't have roots in the denominator, nor can you have negatives in the denominator. That's always an easy fix, though. You just bump it to the top. So this slope would be negative 2/3. A positive divided by a negative will give you the exact of the same numbers, of course. But if I put the negative on the bottom or on the top, as long as only one of them are negative, you're still going to have a negative result. So we want to push all of our negatives to the top. All right, I'm going to encourage you to pause and try to do the next two on your own. Let's see how you did. So slope equals negative 2 plus 2 over 3 plus 1. So in the order that I did it, I got 0 over 4. Now, before I write down what that answer is, I want to do the next one. So slope is 2 minus negative 4 would be 2 plus 4 over 2 subtract 2. That would be 6 over 0. Okay, one of these numbers are good, and one of these numbers are really bad. Hopefully you remember from your algebra days that we have what's called undefined versus the number 0. So one of these is the number 0, and one of these is the number undefined. Not the number undefined, it's a value that's undefined. So here's one way that I learned from kids. I never knew this until I started teaching. Somebody at the middle school came up with this idea. Okay versus no good. So think about it this way. If you have nothing and you divide it among your 4 friends, how much does everybody get? Everybody gets nothing. So it's okay to have a 0 on the top, because a 0 on the top ends up with the answer 0. This is saying take 6 people and divide them into nothing, or 6 markers and divide them into nothing. You can't do that. You could subtract them into nothing. You could subtract the markers and take them away, but you can't divide into nothing. This is what we call undefined. Undefined. It's no good. So I like this little thing, this little setup. So when the zeros on the bottom was no good, that means you're going to have an undefined answer. All right, underneath each one of these, I would like you to tell me which way, if a line had this slope, which way would the line be going from left to right? We always read things left to right when we talk about slope. So underneath each one of these, tell me what that line looks like. Like you should be saying like upward or downward or something like that. All right, let's see how you did. So this has a positive slope. So from left to right, this would be going upward. This line has a negative slope. So from left to right, it would be going downward. And then people get these two mixed up all the time. Think about it this way, or this is the way I recommend thinking about it. If you have a slope of 0, I always think about putting a marble on a line basically, or on a surface. And if that surface is perfectly flat, if it has no slant to it, how much will the marble move? It won't move at all. So what would it look like if you have no slope? If your marble doesn't move at all, your table would have to be perfectly horizontal. If you have undefined slope, that means that your graph can go up or down as much as you want, but it has no width. It goes nowhere left and right. So this makes no sense. The only way that you could have it is a vertical line. So undefined slopes are the same as vertical lines. Horizontal lines have slopes of 0. All right, so in this case, I gave you 2 points. I did not give you a picture. Now, if I give you the picture, you don't have to go through this process of finding slope. You can just use the rise over run feature. That saves us a bunch of time. So I'm going to find 2 points. We call these the lattice points. So find 2 nice points. I'd say that's a nice point. That's a nice point. There's another nice point. It looks like down here there would be another one. But those are what we call lattice points. Lattice points are points that are perfectly they have integer, whole number, integer coordinates. So I wanted to figure out the rise and the run here. So there's 2 ways to figure this out. You can go from left to right. And you can say, how much did I rise? 1. How much did I run? 3. So my slope would be 1/3. Now, just to point out, you don't always have to go left to right, but you have to pay attention if you're going to go right to left. If I'm going right to left here, I would go down 1 and I would go backwards 3. I don't recommend going that direction, but sometimes you have to because you run out of room. And in this case, it's still going to give me the slope of 1/3. Down 1, back 3 is -1 over -3, which is positive 1/3. All right, let's try the next one. Actually, you should be able to do most of these on your own if you want to pause and go for it. There's a lattice point. There's a lattice point. There's a lattice point. I only need 2 of them. Now, I can use these. I'm going to show you that you don't always have to go in order. If you go in order, you're going to get a slope that is already reduced. But if you don't, that's fine. You're still going to get the same overall slope. Let's see. So let's go. This time I'm going to go down 1, 2, 3, -4. And I'm going to run 1, 2, 3, 4, 5, 6. Remember that when you count things on the coordinate plane, where you put your pencil, that's 0. And then you start counting -1, -2, -3. You don't go 1, 2. You're not counting the dots. You're counting the gaps in between. Okay, so my rise is -4. My run is +6. -4 divided by 6. My slope would be -2/3. I reduce the 4 and the 6. I get -2/3. Then the next one, we're talking about our horizontal and vertical situations. I mean, there's lots of lattice points here. I'm just going to pick 2 random ones. All right, how much do I rise? 0. How much do I run? 4. So what's 0 divided by 4 is 0. A slope of 0 is where you put the marble and doesn't roll anywhere. So obviously the last one must be a slope of undefined. And just to sort of put it in perspective so that you have a way to think about it. If I highlight any 2 points that are lattice points, I could rise any amount that I want. In this case, I decided to rise 3, but how much do I run? 0. And from a physical point of view, if you try to put a marble on this, it wouldn't even roll down. It would just fall down next to it. It wouldn't roll down the side of this line. It would just fall. That's why it doesn't have any slope. You can't even attach to it. Okay, then let's see. Okay, we've got some points and we've got a slope. Pretty straightforward stuff here. I'm going to start with the point. The point is -2, -1. Remember, you do the x, then the y. A slope, if you don't have a rise over run, you can easily make the slope into any fraction by putting it over 1. So you would rise 2, run 1, rise 2, run 1, rise 2. I ran out of room. I like to draw as many as I can before I grab my straight edge. And then we play connect the dots. Find 2 nice points, or no, sorry. Start with the given point, 2, 4. 1, 2, 1, 2, 3, 4. Slope is undefined, so you want to make this connection. Undefined means that the marble wouldn't even be able to roll along the shape at all, along the side of the line. So this is a vertical slope. Slope would be -3, +2. This has a slope of 0. That means if you put the marble on it, it won't be able to roll anywhere. This has got to be a flat table. Come on. And then finally, oh, this one's a little bit sneaky because of the negative. So 1, -4 starts me here. Now, where's this negative? Is that with the 3? Is it with the 2? Is it with both? Well, let's think about it for a minute. Let's write it up all 3 ways. So -3 over 2, 3 over -2, and then give it to both of them and see which, if all these work or if one of them doesn't make sense or if none of them make sense. So overall, would you say this is a positive or a negative number? -3/2. Hopefully you would say that's a negative number. Is this still a negative number? A negative divided by a positive? Yes. A positive divided by a negative, is that still? Yes. A -3 divided by a -2, is that still positive? The answer is no. This is the one that's no good. This is out. You cannot give the negative to both of them. You can either give it to the top or the bottom, but not both. Well, normally I would give it to the top, and so from here I would go down 3, but I ran out of room already. So I'm out with this one. I'm not going to do this one. Instead, I can go in reverse, and I'm going to go up 3, 1, 2, 3, but remember that you have to go back 2. 1, 2, 3, then back 2. Grab my straight edge. Play connect the dots. So hopefully that felt like old news. It should be. You've been doing that since probably, 6th grade? All right. But I wanted to talk about it, make sure remind you of it, and make sure everybody had seen it at least one more time. So the last part, the second half of this, is coming up with the different equation forms based on a certain amount of information. So we have slope-intercept form. Slope-intercept form is y equals mx plus b, probably the most famous of the forms. So x and y are your variables. So what does m and b stand for? We talked a little bit already what m stands for. That's your slope, and then b stands for the y-intercept. So we got slope-intercept form, we got point-slope form. Point-slope form, maybe you remember this one. This one is really helpful in AP Calc. That's when you're really going to want to know it. Actually, we move into something called Taylor form, but it's basically point-slope form with a slight adjustment. Anyway, y subtract y1 equals m times the quantity x minus x1. Okay, so we've got a couple of y's in here, but we got to be careful. This y is the variable y. This y is the variable y. This y1 and this x1, those are the point that we're picking it from. That's why it's called point-slope form. Just like this is called slope-intercept because it tells you the slope and the y-intercept. Point-slope form, you need a point. And in this point, to separate the x and the y's, we call this the actual point is x1 and the y1. And then m again stands for our slope. Now this one seems a little bit nasty, but it's actually just the slope formula rearranged. So if I took the slope formula, which is m equals y2 minus y1 over x2 minus x1, and I cross multiplied this up to there, look at what you've got. That's all it is. So it's the slope formula with this denominator moved to the other side. And then the last form, the one that I probably use the least, but it's really the easiest one, usually based on a story problem. This is usually the easiest style of equation for a line to come up with. And it's ax plus by equals c. A, B, and C mean nothing. So there is no, A is not the slope, B is not the y-intercept, C is not the y-intercept. A, B, and C don't really stand for anything. The reason we like this form, you might say, well, then why do we ever use it? Like I said, it's a really nice form when you have two independent variables. So how often I get my hair cut and how often I mow my lawn. If there was some sort of a function I wanted to relate those two variables together, they don't depend on each other, but I could still try to come up with a relationship on how often I cut my hair and how often I mow my lawn. They don't depend on each other, but I could still find a relationship between them. Okay, so using these forms, we're going to be given some information. We're going to try to write an equation in those forms. I usually try to write the easier of the two first. So in this case, I'm given a point and the slope. So which one of these two would be easier? Obviously, point slope would. I mean, it literally is called a point and a slope. So it's just a matter of plugging and chugging into the right places. So this is the point, that's the slope. So it says y minus y. Our y is a negative 2, so that would become y plus 2, equals the slope is a 3, x minus x. So notice the x and the y stay as x and y, and then the x1 and the y1 get switched into points, numbers. So now let's do this in slope-intercept form. There's two ways to go here. If you wanted to, you could just take this and distribute it and rearrange it so that y is by itself. If you see that way, go for it. I'm going to show you another way. Another way is to take the y equals mx plus b and start to put in all the information that we know. So y equals mx plus b. Do we know the slope? Yes. So I'm going to start off with y equals, my slope is 3. X plus, do we know the y-intercept? Not this, nope, not this time. So now we need to figure out what the y-intercept is. So they gave us an extra hint though. This is still x and this is y, so I can put x and y in there. So now y is negative 2 equals, 3 is now a known quantity, so I put it back in orange. X is 1 plus b. This is now something that we can solve. Negative 2, 3 times 1 is 3, plus b. Move over the 3, that's negative 5 equals b. And so we get the equation y equals. My slope is 3. My y-intercept is negative 5. If you did it by distributing, actually, let's just do it real quick. I'll show you it's the same thing. Y plus 2 equals 3x minus 3. Bump over that, y equals 3x minus 5. Same result. Let's have you try. I'll encourage you to pause and see how many of these you can do on your own, and then come back. Maybe do one at a time and then come back and watch. See how you did. Okay, let's see. So point slope. In point slope, I need point. Good, I've got 2 points, so either one of these would work, but I need the slope, and I don't have the slope, but we just spent the front half a notes going over how to find the slope between 2 points. So it's y minus y over x minus x. So I get that my slope is going to be 1/5. So now when I use point slope form, you can put it into either form. It doesn't matter which form you want to use. So I'm going to use I can never decide on colors. Gosh, it takes me forever. But it looks so cool when I have all the good colors up there. I know. Make a decision. 1 second left. All right, going green. So point slope is y minus y. So y minus 1 equals slope 1/5 times x minus x. What do you think? All right, like I said, or we could have used, I used this point for my point in the point slope. I could have also used this point. That would have been y minus 0, which you don't have to write, but I'm going to write it just for understanding purposes, of x plus 2. So it's up to you if you want to distribute from here and try to get this into slope-intercept form. I'm going to try it from the perspective of plug and chug. That's the way I learned how to do it, and that's the way it makes most sense to me. So I'm going to start off y equals, I know the slope is 1/5. I don't know x, I don't know b. If I knew b, I would be done. I could just plug it in. So to find b, I've got to plug in x and y. So I'm going to pick one of these. It doesn't matter which one. I'm going to pick this one just so I can talk to you about fractions. So 1 equals 1/5 times 3 plus b. Clean this up. 1 equals, now remember how you multiply fractions. You make this into a fraction, and then you multiply straight across. So that's 3/5 plus b. Now I'm going to subtract from 1. If you can't do this in your head, that's fine. Go to the margin of your paper and try to figure it out. So we want to do 1 subtract 3/5. Well, for me to subtract that, the number 1 must have a common denominator. Well, first it must be a fraction. Now I can turn this into any fraction I want because it's 1. So 5 divided by 5 is what I'm going to pick. So 5/5 minus 3/5 gives me a b value of 2/5. So now I could take that b value with my slope that we figured out up here and get an equation y equals 1/5 x plus 2/5. Like I said, I encourage you to pause here and try to do these on your own. Okay, for point slope, I've got points. I don't have the slope. So my slope needs to be calculated. So that's -1 plus, nope, -1 minus 4 over 1 minus 0. That would be -5 over 1. So that's just -5. If you want to put it back there in -5, you want to plug it in that way, it's fine. It's a little mathematically embarrassing, but it's legal. So I could go y subtract 4 equals -5 times x subtract 0. Or y plus 1 equals -5 times the quantity x subtract 1. Now you can distribute this, Or you could learn this other way. And the reason I like this is because most people don't memorize point slope form. Almost everybody remembers this because we say it so much, but not as many people can remember this trick. So if you can remember this, go for it when you distribute. But if you can't, then you're going to want to know how to plug and chug into y equals mx plus b. Now this one's especially easy. I'm not even going to show my work on this one because y equals, my slope is -5, x, what is this? If your x value is 0 and you've got a y value, that's your y-intercept. So game over there. If you did it the long way, hopefully you got to that same spot. Okay, last one, point slope. They gave me the slope, so I don't have to calculate that. Point slope, I only have 1 point this time, so y plus 2 equals 4/3 times the quantity x minus 2. And then to write it in slope-intercept form, I've got to do some plugging and a chugging. So that would look like y equals, slope is 4/3, another fraction, ug, x plus b. I have to now solve for b. So that means they need to tell me what y is, and they told me it was -2. Equals 4/3 times, my x value is +2 plus b. -2 equals, remember this is over 1, so this becomes 8/3 plus b. And then from there, I'm going to bump this to the other side. I don't have room to do it here, so I'm going to do it underneath. So I want to do -2 take away 8/3. Make this a fraction. Common denominator. I'm lazy and usually just write it above it. So I would have to times this by 3. We just have to times this by 3. So it'd be -6 minus 8. So that'd be -14/3. And now that we've found the y-intercept, we can take the slope and the y-intercept and make one equation, y equals 4/3 x minus 14/3. All right, folks, there's your notes. Go get that homework.